All right, it is 8:30 Pacific time here, so let's go ahead and get started. Welcome to our webinar that we're hosting today on the MCAD Collaborator, part of our Advanced Technology series that we've been hosting with Oasis Sales. Again, my name is Kyle Lake. I'm an application engineer with Oasis Sales that specializes in the Xpedition flow, and today we'll be talking about the MCAD Collaborator option within the Xpedition as well as PADS Professional space. So today I'll be talking about it in the PADS Professional space, but the MCAD Collaborator is the exact same functionality throughout PADS, Standard and Standard Plus, PADS Professional, as well as the Xpedition Enterprise flow. Okay, so if you're using any of those tools, welcome. Hopefully it will be a little bit helpful for you in understanding how that kind of technology can work between the eCAD and MCAD domains. If you're not using any of those mentor tools, hopefully there'll still be some good information on what is capable with MCAD collaboration. Okay, so just a little bit about what we're going to be covering today, how we can seamlessly and very easily exchange data between the eCAD and MCAD tools. I know this can be a big pain point for a lot of people because we kind of throw those design changes over the wall and not really that much collaboration can happen between the eCAD and MCAD teams. So what we'll be able to do is exchange that data and then accept or reject those changes directly in either that electrical tool or the mechanical tool. So we can see what those changes affect and then easily accept or reject those and send a response back to the respective tool. Hopefully this will allow us to eliminate those costly respins due to space requirements. We can see space requirements between the enclosure and tall components, for example, or just component placement and board outline space. So hopefully this will allow us to ensure that the quality and performance are optimized with those tight mechanical constraints, just to, again, enable the very seamless exchange between eCAD and MCAD data. Just a little bit about Oasis Sales, if you're unfamiliar. We have been a premier mentor, now a Siemens company partner for over 16 years. So we are located in the Midwest, mostly, of the United States. So if you're one of those states, hopefully you're familiar with us at least. We offer solutions for printed circuit board design, wire harness design, simulation, mechanical tools. So essentially, a lot of the gambit that Mentor Graphics offers, we can help you find out which solution is best for you or understand how to use what you currently have more effectively. Here's just a little map of our area that we cover. So if you're in one of those states, please feel free to reach out to us. I know we might have some other people in other parts of the country. So thanks again for attending, everyone. We do host quite a few webinars, Oasis Sales does. So if you're interested and like what you see today, please check out our website, oasissales.com, and you'll be able to find a link to all of our archived seminars that we kind of host. We host seminars on different aspects of the tool, different features, and then also different packages that you might be able to be interested in. We also do have a YouTube channel if you want to search through it that way as well. Okay, so here's my contact information. If you guys have any questions after what we discussed today or see, please feel free to maybe take a screenshot of that and reach out to me at a later date. You can give me a call, shoot me an email, and I'm more than happy to help out or discuss this a little bit further. I do want to point out as well, there is a chat box in the GoToMeeting client. If you have any questions, please feel free to put those in the chat box and I'll address those as they come up or as they're relevant. Okay, so let's hop into it. So here is kind of what Mentor can offer for your design, your electronics design capabilities. So we have Xpedition, which is an enterprise-based PCB layout tool, which has very powerful layout capabilities as well as data management capabilities and collaboration. So usually this is for companies that are tackling high-end design needs, as well as maybe they're spread across the country and need to be able to collaborate very effectively together. PADS, it's a project-based PCB design tool. It's been around for many, many years. It's very capable as well. It just doesn't offer the enterprise data management and collaboration capabilities that Xpedition does. Hyperlinks is an industry standard simulation and analysis tool for your printed circuit board design. We can, within Hyperlinks is a large family of simulation tools that cover signal integrity, EMI, and then even down into the thermal type of checking as well. And then Valor, kind of on the manufacturing side of things, we can do manufacturing and assembly checks in the Valor tool that allows you to hopefully increase your yield and maximize that. I always like to show this slide, just showing how the trend of printed circuit board design has gone throughout the years. So the main takeaway from this chart is really that red line, what is showing the average leads per square inch that are just continuing to increase. Boards are staying roughly the same size. Layers might be increasing as well, but they're just packing more and more components onto the board, making it more difficult to route, making it more difficult to place, which can be very critical in the eCAD and MCAD collaboration domain. So you can see on the left-hand side, that was a board designed in pad layout. It's a very dense, very packed in board that had to utilize some of the eCAD and MCAD collaboration in order to get that to work correctly. Okay, so what are some historical barriers to why eCAD and MCAD collaboration does not always take place? I think the biggest issue is that there's always just been a traditional separation between the disciplines. We've got the MCAD world over here and the eCAD world over there. And it's kind of been that the MCAD drives what the eCAD has to follow. So here, we're gonna just try and bridge that gap and make more collaboration possible. They're typically working with two entirely different tool sets, which is kind of a given because the mechanical engineers are either going to be working in PTC or NX, or even SolidWorks, and not understand any of the vocabulary or the vernacular that the electrical designers are going to be using. So it's essentially just two different worlds, and we're trying to bridge those together in order to streamline the electrical design process. Impacts of poor collaboration. We can definitely have inconsistent data or communication between the eCAD and MCAD world. A lot of the time you're doing critical placement in the electrical world, or we import an IDF file. It's been a very typical type of design flow in order to help with board outline as well as some critical component placement. Usually that's a one-time thing. You get your first IDF file and then you go through your design. Occasionally you can get another IDF file with updated placement, and you've already done some of that routing that can really throw some issues into the mix. So with this, it's basically a one-off file that's sent, and there's no what-if evaluations. We can't collaborate and say, well, what if we moved it here instead of where you're proposing it over on this other side of the board? This allows us to have some negotiation between the eCAD and the MCAD engineer and just work collaboratively in order to engineer the most effective solution for your design issue. Okay. Just again, I am not seeing any questions, but if those do come up, please enter those in the chat box and we'll discuss those. Okay, so what is the MCAD Collaborator? So on the left-hand side, you'll see a screenshot. That's actually within PAD layout. Okay, so that is PAD layout, 2D layout on the left-hand side, of course. And then we have a 3D view that is basically the same 3D view through PADS, PADS Professional, as well as Xpedition. So again, it's essentially all of the same feature sets that we'll be talking today is in all of those tools. And then in the middle of that screen, that's the MCAD Collaborator dialog box. This allows us to have, again, that real-time collaboration between the electrical and mechanical teams. Okay, so what we can do with this tool is we can propose changes from the electrical world. First, we would probably want to do a baseline. So we'll send a baseline package from the mechanical into the electrical world to go ahead and get started. And then we can start sending proposals back and forth between the electrical and mechanical team. Okay. So this is based on the ProStet standard. It's an XML format. It's called just ProStet. So if you're familiar with that, it works with many of the different MCAD vendors. So it does have support for all of those different tools. So if you're unfamiliar with that particular standard, take a little bit look into it, and your mechanical tool definitely should allow for that type of exchange of data. So once we send those proposals, both in the electrical and the mechanical world, we can accept or reject that modification and then send comments back and forth in order to understand why that was accepted or why that was rejected. And ultimately, hopefully this will reduce the design time and hopefully avoid any respins that might have been caused due to poor collaboration. Okay, so just a little bit about communication format. I'll just briefly touch on this slide. How it's been done historically, again, is with that IDF. So IDF has been around for decades, and essentially it's two files that allows us to exchange board outline, mounting holes, placements, and then any other sort of arbitrary electrical data as well. So, I mean, it works. It definitely works. A lot of people utilize this very effectively to collaborate between that eCAD and MCAD world. What IDX brings to the table is it's an incremental data exchange. That's what IDX stands for. Okay, so the incremental data exchange is we first are going to send that baseline that contains all of the design data. Okay. Then every other proposal that we create is the incremental data exchange. So the incremental, once we create that proposal, it's only going to contain the data that has changed from that baseline. Okay, so that's why it's called the incremental data exchange. Allows us to have a smaller file and not have to exchange the entire design data back and forth every time that we're changing files. So if you're currently happy with why would I want to use this IDX format over our historic IDF? Okay, so I know a lot of people have success with IDF. It works very well. There's just a few benefits that we can have. So IDX allows us to establish that baseline again. So the baseline and then every change beyond that is just that incremental data. So we're no longer having to export an entire EMN and EMP file as well, and then change that back to the mechanical team. So that can cause just a little bit more bogging down of your system, have a larger file. We also have the ability to evaluate those changes. Okay, so this is a picture on the right-hand side of the dialog box in the MCAD Collaborator in PADS layout, and this allows us to see all of the proposals and the responses that we've got from the mechanical team. Okay, so what these files show is if you click on the file, it shows you exactly what has changed between the last response or proposal that we had. Okay, so we first send that baseline, and then every proposal from there on only contains that incremental data exchange and allows us to see what exactly has changed between this proposal and the baseline. Okay. Just some other benefits that this allows is it ensures traceability. What changed, who changed it, why it changed through the use of comments, and then when it changed as well. So this just allows us to have a very effective traceability factor when it comes to changes between eCAD and MCAD. Okay, so here's just a small eye chart on the collaboration flow of how we want to use this tool most effectively. So the pink is in the eCAD domain essentially, and the MCAD or the blue dialog boxes are in the MCAD domain. So essentially what we want to do is first create that baseline in the MCAD world and then import that baseline into the eCAD world. Now we're effectively in sync. We've got the board outline, maybe some critical placement done, and we're in sync between those. Okay, so now in eCAD world, we maybe are going to finish up all of the placement of our capacitors and non-critical components, and then create another proposal and send that to the MCAD world. Okay, so this will update the placement of other components in the mechanical tool, and again, we're in sync. Okay, and then we can just keep on going through that process as component placement changes, as the enclosure changes, or even as much as the board outline would change. So we can always send that data back and forth. Okay, so just some best practices on how to use this tool most effectively. First, we want to make sure that we utilize that IDX data in order to create the baseline. The baseline is essentially what we are working from all of the time. So the baseline is what's used to reflect all of the changes or proposal files that we send between the two domains. It's recommended that we drive the baseline from the MCAD domain just to include the board outline, those mounting holes that they need for their enclosure, and then any restricted areas and maybe some critical components that the mechanical engineer can place in their tool. We do have the ability to place notes or comments on every effective change that we have from eCAD to MCAD. So if I need to move this component away from the board edge or closer to the board edge or flip it to the back side of the board, we can include a note and kind of help understand why we're making that change instead of just following it blindly. And the last thing is just to synchronize data between the electrical and mechanical teams as early and as often as possible. So I'll show how simple and quick that is to do, and that way we know that we're totally in sync between these two different worlds. Okay. All right, with that, I'm going to go ahead and actually hop in and demo some of the stuff that we just talked about. Again, just to reiterate, there is that chat box. Please feel free to enter in any questions that you may have. I don't see them yet. All right. Okay, so first I'm going to actually go ahead and show what we have in the layout space, the electrical layout space. So this is PADS Professional. Again, I'll be driving from the PADS Professional layout environment. Okay, so this will allow us to collaborate from electrical data in the 2D space, as we see on the right-hand side. This is just the 2D layout environment that everyone's probably familiar with. And then on the right-hand side, we actually have the 3D representation of the board. Okay, so as of right now, essentially all we have is the board outline. Okay. If you're unfamiliar with PADS Pro, we do have the Component Explorer that shows all the different components that we have to place on this design. So if I really want to, I can go ahead and place that component directly, and we can have the ability to go ahead and do 3D placement within this environment. Okay. All right, so in order to start the MCAD collaboration, well, I'm going to go ahead and look at the 3D tab. So this is the 3D tab that allows us to instantiate the 3D view of our particular design that we're working with, import mechanical files such as an enclosure or a heat sink or fan, anything that you want to bring in as a step file, we can do through this little utility here. We also have the ability to start that MCAD Collaborator dialog box. So this will excuse me, allow us to start using and sending those incremental data exchange files between eCAD and MCAD. Okay. So first, I'm just going to take a look at the setup, and it's very easy to go ahead and set this up in order to allow us to work between eCAD and MCAD. So we do have the ability to change some options such as version, units that we're using, the extension, and then the actual communication type. So if we want, we can send changes as I have it set up right now, is to just create that file in a file directory and it'll exist there. We also have the ability to connect this to your email, and as soon as we send a baseline or a proposal, it will generate an email with that IDX file attached, and then we can go ahead and start working with it that way. The last thing I am going to show is the message path. This is important. We just want to make sure that we have the exact same folder pointed to on the eCAD world and the MCAD world. That way we just can work with the same data. Okay, so right now, we don't really have anything to change from the eCAD world or the MCAD world. We've just finished our schematic, for example, and now we're trying to transition into layout. And what we want to do first is understand the board outline that the mechanical team has kind of come up with due to spacing requirements, due to what they are designing for the enclosure, and where all those mounting holes need to be set up at. So to facilitate what I'm going to be doing in the mechanical world, I have NX. So this is Siemens NX. If you're unfamiliar, this is another enterprise level mechanical package that Siemens owns. So maybe some of you are using that, hopefully. But again, this is the same kind of process, whether you're using PTC or SolidWorks or any other mechanical tool, this should basically be the exact same process. Obviously, the dialog boxes might change, but we're going to still be changing the exact same data between eCAD and MCAD. Just to make sure that our settings are set up correctly. So we've got the IDX Collaboration, and just to make sure that we're pointing to the same folder location, that's where we're going to be sending all those intermental data exchange files. Okay, so as you can see, we have the board here in NX. So we have the board outline, some mounting holes, and then it looks like all the critical connectors that are necessary on this design. That's what the mechanical team has gone ahead and created the board outline, placed those mounting holes, any fiducials potentially, and then the connectors that are necessary in order to meet in between the enclosure and the outside world. Okay. So once the mechanical team has gone ahead and done that, what we can do now is export a baseline. So we have in NX this IDX tab that allows us to control all of those incremental data exchanges on when we want to import, when we want to export, etc. So currently, I'm going to go ahead and export a current baseline. So this is what we wanted to talk about in the best practices, is we want to drive the baseline from the mechanical team. Okay. So just to show what's going on here, I've got the baseline file. It's going to that collaboration directory that we have both tools pointed at currently, and I'm just going to go ahead and hit OK. It's going to give us a log file here that shows the board size and anything that's been placed on that board currently. So drilled holes, components, number of components, any other errors or restrictions that we have there. Okay, so that's all we have to do in the mechanical world. We've gone ahead, created this design, and sent that baseline file. So now, once I hop back into the PADS professional world, here in that MCAD Collaborator dialog box, we have that baseline file that we just created. Okay, so again, it's looking at what we want in that directory, and it understands that that IDX file is probably what we want to work with. So I'm going to go ahead and click on that IDX file, and you'll see as soon as I click on that baseline file, it shows us exactly what has changed in that baseline file, or what there exists in that baseline file. It breaks it down from the route border, the route out of the board outline, any mounting holes, and then the components are all sorted between top layer and bottom layer. Okay. So what's effective about this is if I click on this highlight, unhighlight graphics icon here, this will actually show us what is included in this file right in the design. So I'll make this a little bit smaller so we can see. So for example, if I click on J2 and have it highlighted, it's actually going to show where that component is in the 3D space. Okay, so probably most effectively, first, if I take a look at the board outline, I'll select that, and you will see it highlights what that board outline looks like in the MCAD domain and what it wants to bring in through this IDX file. Okay, so if I click on the entire IDX file, it should hopefully show us everything that's included in that IDX file and kind of see what's going to be on the board as soon as we click apply. Okay, so it might bog down my system just a little bit, but that's what it's going to look like when we hit apply and bring in this baseline file. Okay. So the tool is intelligent enough that it understands the reference designators from coming in from the mechanical world, and it will automatically place those reference designators in those exact spots in 3D as well as 2D. All right, so all I have to do now is go ahead and click apply. And you'll see, as easy as that, we've gone ahead and updated all of the placement data, the board outline, and brought in all of those components directly from that IDX file. Okay, so that's the baseline. Very easy to export from NX. Very, very simple in order to bring that into our eCAD domain as professional here. Okay, so now, for example, if I need to go ahead and change the placement, again, I can do that in a 3D space. I'm looking a little bit backwards here, so I'm going to use the top view in order to have the same view between those two here. So you'll see 3D placement allows me to either select the component in 3D, or of course I can move it in the 2D as well. I do see a question from Randall, and it looks like you have a few cutouts and they're not coming across in the IDX baseline. All right, well, I'm sorry to hear that, Randall, but that is something maybe that we can talk about a little bit further offline and understand why that's not happening. Maybe we could try the newer version, IDX 3.0, in order to more effectively bring all that information in. Okay, so what I'm going to do now is I'm just going to go ahead and adjust some of these, the rotation and the location of some of these components. So I'm just going to go ahead and move this connector and rotate it. And just, I'll play around here and just actually flip this to the opposite side of the board as well. Okay, so this is essentially all we have to do. We could go ahead and place other components from the Component Explorer as well. I'll just place this IC, for example. And now we can go ahead and actually do all the rest of our placement in the electrical world. Okay. So now what we want to do is go ahead and send a proposal back to the mechanical team. Okay. So it understands that there's been changes from our baseline. That's why we have this get PCB data is highlighted, showing that we need to get the PCB data and send a proposal back to the mechanical team. So I'm going to go ahead and click on get PCB data. And again, it shows us exactly what has changed. Okay, so it does it in kind of a nice graphic way. It shows us that this component has been rotated and flipped to the other side of the board. This one's just been rotated and moved. And this IC here has just actually been placed onto the board. Okay, so like I was saying, if I need to put a note or a comment on that, I can very easily select J13, for example, and we can say need to flip. Okay, so we need to flip this to the opposite side of the board. So comments like that can be very effective, again, and to enable to help the mechanical engineer or the electrical engineer understand why we need to make that change. Again, this tool is all about trying to bridge the gap between the eCAD domain and the MCAD domain. And obviously, effective communication can very help that process out. Okay. All right, so you'll see that we have this proposal as this file selected as a proposal. We wouldn't want to send another baseline because that's going to overwrite all of the work that we've done. So I've got that proposal, and now all I have to do is hit send. Let me put that note back in. Okay, I'm going to hit send. All right, so what it shows us in the history is it shows us all of the history of what has transpired between our collaboration. Okay, so we've got that baseline, gives us timestamps of everything, and then the proposal. So we can easily see what's changed between revision through this dialog box here. Okay, so you'll see at the bottom left-hand side of this MCAD Collaborator dialog box is proposal sent. Now we are awaiting the response from the mechanical team. Okay, and again, like I said, if we do have it set up to use that email server, very easy to understand how it gets emailed, and the person on the mechanical team right now would get that email and know that they have to either accept or reject that change, hopefully within a adequate time amount. All right, so now I'm going to hop back into the mechanical tool and show how we can bring in this incremental data. Okay, so now all I have to click on is import this incremental data from the electrical team. This allows me to select that file, and it should automatically be pointing at the collaboration directory that we set up in our initial setup. Okay. So we'll see we've got the baseline that we already created, and now this is the proposal. Okay, so here is the dialog box for bringing in this incremental data. So again, only exchanging the data that has changed between the baseline and now this new incremental data file. You'll see everything that we have here. We've got any changes to the board itself, any changes to any of the areas that we have, or any new holes, for example. So in this particular file, all we've done is placed a new component. You can see here the status. We have a new component that we need to place. It already has a reference designator, the package associated with it, as well as the part number. So all of this data is coming over in that incremental data exchange file. Okay. Here's the comment that we need to flip. It comes over with that. Again, just helping us understand why we're going to place that. Okay. So what I can do in this is if I click on the preview changes, this will allow us to see what has changed between that old revision. Okay, so I can individually click on those, and it's going to highlight where we want those new parts. Okay, so on a one-off basis, for example, on a one-off basis on all of these changes, I can go ahead and actually, so for example, if I preview the change again, sorry, I accidentally closed this out. I can actually see where these new components are going to be placed. Okay, so it looks like that is going to create a collision, for example, and instead of accepting all of the changes, I'm just going to go ahead and reject that. Okay. So I've accepted these two changes for U37 and J8. Now I can just go ahead and change the response file, the name, and then add any comments that I want to. Okay. Once we're ready, I can just hit OK, and that's going to again send the response back to the electrical world. Okay. Hopping back into PADS Pro layout, we'll see that new response that I just created. Okay. So what's important here is it shows us our different components that we have. Okay. So automatically, due to the fact that this checkbox is not checked for J13, that's where we understand why that component or why that has been rejected. Okay, so that checkbox is the accept or reject change that we've created back in NX. I can click on each component individually and see how it's changed. And when I'm happy with that, I can just go ahead and hit apply, and it's moved those components. So you'll see it did not move the connector that was going to create that clearance issue. It only moved the components that were actually accepted. Okay. So what we've done so far is gone ahead and create the baseline file in order to create the board outline, do the critical components. Now we've gone ahead and created a proposal in the electrical world and sent it back to the mechanical world for approval or rejection. Okay. What we can do is the exact same thing in the mechanical world, for example. If I want to move this component, this connector, for example, in NX, and I can do the exact same thing in this domain as well. Okay, so just some simple changes like that. Now I can go ahead and export a proposal from NX. So this is doing the exact same process. It's just showing us from the MCAD world, we need to change some components and now update that in the eCAD world. Okay, so the exact same thing. I'm going to go ahead and export a changes.idx file and bring that into the PADS Pro world. Okay. Again, it gives us a nice graphic that shows where those components are, it highlights them on the layout and shows exactly where they're changing their location to. Okay. For example, if I don't want this J14 move, I can hit that and just hit apply. Okay, so now we've gone ahead and updated this in the electrical world, and now we can just send that the response that we've gone ahead and accepted those. Okay, so I hope that's done an effective job of showing how we can very easily exchange data for placement, board outline, route border, fiducial mounting hole, anything like that. We can really seamlessly exchange the data between electrical and mechanical world. Okay. Well, that's essentially all I had planned to show today. I know it's not the longest webinar, but thank you for taking time out of your post-4th of July day to attend. I do appreciate it. Again, here's my contact information. If you have any questions or want to maybe play around with the tool a little bit more or need help with your current setup, please feel free to contact me at that information below. All right, this has been recorded, so we will be sending it out via email, as well as it'll be on our YouTube channel. So if you'd like to take a look at it in the future, please feel free to do that. All right, well, thank you very much for attending. I don't see any other questions in the dialog box. I hope you all have a very nice day.